Hi, this is Alok Srivastava from San Francisco. Thank you to Dominic and the Biological Engineering Collaboratory for organizing this series. Um, Let me begin by sharing my slides. And go to the first. So my paper is titled, No Colligation Without Commensuration: How Torricelli and Chargaff successfully bound phenomena through measurement and thus bound fact through concepts. My concern is with the relationship between artisanal knowledge in science and theoretical knowledge in science, and how they generate each other, support each other, one comes first and then the other comes, and that kind of phenomenon. So my question, if I state it, is how do new material behaviors that have no discourse or practice in contemporary science make it into scientific discourse with their own specificity and selectivity? And how is it that artisan scientists working with such material behaviors isolate phenomena that they cannot theorize about and make nature signals readable, intelligible, with new messages, new concepts and measurements? So I'm using this language of nature signals that are not part of our discourse and science's messages that are part of our discourse. Artisan scientists working with materials and their arrangements, when they find new behaviors, the nature signals, the contemporary science cannot make intelligible. It doesn't have science messages. Generation of new class of facts that are qualitatively outside the contemporary discourse of science, practice and theory pose novel problems. And that was the case with Torricelli and Chargaff. So an example is Darwin, who sees a series of facts, they're not intelligible, and then he does work to make them intelligible. In his own words, he says, series of facts seem to be connected together by some common but unknown bond, which is essentially related to the principle of life. But what is that bond? We see in these facts some deep organic bond, but what is this bond, right? Not reading the whole paragraph. And then he comes up and says, this bond in my theory is simply inheritance. And only that cause can explain these properties of organisms. Okay, and this is an example of how Darwin was able to go through that transition, make intelligible, make nature signals have a corresponding message in scientific discourse. So I'm organizing two different groups: signals without messages. That's an example of somebody like Torricelli, who devises an experiment that is able to make a difference in various situations, right? This vacuum at one end of a seal tube with mercury, and in a bath of mercury, the height of the mercury column, which I show you here, right? And when you take this device in different situations, the height changes. So now you've got a signal that is a situated signal, and it's a difference of a similar kind, but we don't have scientific discourse on it. But as Torricelli goes on, we do end up having. So artisan scientists playing with material configurations often create situations that offer signals without messages. An opposite situation is there are messages, there's some intelligibility, but there is no corresponding material-based signal. Artisan scientists working to find material properties to explain behaviors of higher organizations fall into such situations, messages without signal. When in 1944, a group of scientists showed that it's this boring tetranucleotide, 4-base polymer called DNA that carried inheritance between is the basis of inheritance between bacteria. We didn't have methodology to go and look at the DNA and look for signals. You know, how was this DNA in any species could be consistent and different from the consistency of DNA in another species? This couldn't be characterized. Erwin Chargaff took on this work he had deep knowledge about DNA chemistry and knew the status of analytical chemistry. And he developed a microanalytical technique. And what you're seeing here is paper chromatography lanes showing the decomposition of the 4 different nucleotides. But he developed a technique so that you could find the composition for a whole genome, not pieces of a genome, and hence compare different species and ask which part of the composition was different. And thereby he was able to produce a signal, a material signal from the genome of DNA of the genome of different species, and then noticed a consistency, what Darwin would call a bond of connection. And those were the Chargaff rules, right? And so my claim is that between artisanal knowledge working with materials and theoretical knowledge working with patterns and abstractions, there is work that involves taking similarity and differences in nature of the signals and articulating them and situating them in case collections and theory frameworks. This work is titled Commensuration and Colligation. Commensuration is about measuring things against or in comparison with each other so that you can have a proportion across multiple cases that's a difference that is similar and quantitatively different, but qualitatively similar. And you isolate that dimension of measurement. Colligation is the idea of binding, what binds multiple facts in a single way. And here I want to say that while traditionally we talk about concepts as binding isolated facts, when you have these primary situations where new facts are being generated and they're being brought into a coherence by an instrument, by the development of instrument and clarification of commensuration, the instrument, like a barometer itself, becomes the colligative device, the binding device of a property between different situations. Overall, I want to make a point that there's an engine involved in this kind of artisan work and theory work that of making the bond of connection. Commensuration and colligation have to serve each other by iteratively working out articulation and situation of similarity and difference. This is my gratitude slide. We'll go through it in detail when I give the talk, but I really want to thank Dominic for persisting with me and encouraging me to get here. Okay, thank you. And let me close the recording.